Welcome to C# for Crestron programming. In this first of two videos, we will examine methods for adding timing within our code. While timers can be useful, it is important not to cause unnecessary delays in the execution of our programs while waiting for them to complete. We will be starting with a C# console app.NET framework project called Timers. In our main method, we have set up a console writeLine statement with a readLine method to accept an input. An if statement will evaluate against the user entry and print to the console if a match is found. We are using the datetime.now property to provide a timestamp for our testing. This input from console is indicative of any kind of input into your system. If based on this input you would like to execute a timed action, for instance, trigger an output 3 seconds after the input, you would need a set of code to keep track of this time. There are a multitude of ways to do this in C#, and we will cover some commonly seen options. This first option of thread.sleep comes from the threading namespace, and we will add the using system.threading statement to access this type. Within the if statement, we have a writeLine statement declaring the start of our testing. The statement of thread.sleep with 3000 in parentheses causes the main application thread to essentially pause for 3000 milliseconds or 3 seconds. We can tell this statement is blocking as the writeLine statement on the next line does not execute until after the 3 seconds has elapsed. So what is the main thread of the application? Essentially, you can think about the execution of a program like a highway. At the very least, a highway has a single lane where all traffic has to pass in order. This is the main thread with all code executing in a row. While this linear execution works, it's not very efficient. Processes that need to wait for other data before they can continue will hold up the lane. Other processes could speed up the flow of traffic by running in parallel to the original, i.e. in their own lane. This is where threading comes into play. If you have some time-consuming or communication-dependent code that needs to run, you can use another thread, either managed by yourself or by the operating system, to run the code and push that traffic into another lane. The time-consuming code on our example will be a timer from the system.timers namespace. This timer has various properties and can be set and has an elapsed event to which we can subscribe. The event handler is run each time the interval has elapsed. Here we will start the timer with the built-in method, and immediately afterwards print a statement to console showing that the main thread execution is still proceeding while the timer is counting away in a worker thread. We will also add in a thread.sleep as before to show the second thread is not affected. We can see in the console output, the order of the statements shows parallel execution of threads. Thread.sleep is generally discouraged in event-based programming as you can see its effect on the running application. Timers would be preferred. In our next video, we will continue by looking at an asynchronous operation. Thank you for watching.